In algebra, one of the most important things we will learn is this concept of solving equations. An equation is when we have an expression with an equal sign in it. So what we do is we use the equal sign to help us solve for a certain variable. In this case, it's x. This one's easy. So if we solve this, we would just say x is equal to 1 plus 2 is equal to 3. And so we're trying to get to this final solution of just the variable equals some number. But as the equation gets more complicated, how do we turn that into just giving us the solution? Well, we can do that by adding or subtracting on either side of the equal sign. But you have to be careful, because whatever you do to one side of the equal sign, you have to do the exact same thing on the other side. Let's say you want to add 1 to the left side of the equation. Let's just leave this as an equation. So you have x, and then you have 3. So you would need to add a plus 1. If you add it on this side, you have to add it on this side. And same thing, if you add it on this side, you have to add it on this side. If you wanted to subtract something, let's say x minus 5, then you would need to also subtract it from the other side. Because if you do something to one side and not the other, then the equal is no longer true. It's no longer equal. And that will give us an incorrect solution. If you're going to, say, divide, if you're going to divide by 3, you have to do it to both sides, and you have to do it to the entire side. So let's say if you have x plus 1 and equals 3, and you divide this by 3, you would have to divide the entire other side by 3. But anyway, what we're trying to do is just manipulate both sides of the equal sign to give us the variable equals some number, which will be our solution for the following examples. But let's go ahead and do some. So how would we solve an equation like this? Well, our step 1 is to combine the like terms. So what do I need to subtract from either side or add to give us, to combine all the x's into one quantity and combine the numbers into one quantity? Well, what we could do is we could just try and get rid of the x's on this side by subtracting negative 5x. So we would also need to subtract negative 5x from this side. But that would give us 0x on this side and 30. So that's all that's left on this left side of the equation. And then on this side we have 11x plus 18 minus 5x. We can simplify that further. So we have 30 equals, what's 11 minus 5? 30 equals 6x plus 18. So now we want to, our next step is to get whatever variable we have by itself. So we need to get the 18 out from this side. So let's subtract 18 from both sides. Negative 18. So what is 30 negative 18? Or I'll just write it as 30 negative 18, just so we can see here. Equals 6x. And this will be 0, right? Because 18 minus 18 is 0. So now let's bring this up here. And we have 6x, or we have 30 minus 18 is 12. So we have 12 is equal to 6x. So now that we have all our like terms combined, what we want to do is just get a single quantity of x. So just x by itself. What we need to do is divided by 6, right? Because 6x divided by 6 is 1. But if we divide this side of the equation by 6, what do we need to do to the other side? We need to divide it by 6, right? Because we have to do the same thing to both sides. But let's just simplify that. So 12 divided by 6 is 2. And look at that. It just gives us x. So our solution for this equation is x equals 2. Solution for x. Here we have another equation that we can solve by manipulating both sides. But over here we can just combine like terms first to make things less confusing. So what is 6x minus 21x? That gives us minus 15x. So we have minus 15x plus 58 equals 14x minus 29. So what do we need to do? We need to combine all our x's. So what do we want to do? We can either subtract 14 from this side, or we can add 15 to this side. Let's add 15 to this side because working with positive number x is easier. So I'm just going to add a 15x over here, and then I also have to add it to this side over here. So that would give us minus 15 plus 15 is 0. So we have 58 equals 14x minus 29 plus our 15x. So we can combine like terms. 15 plus 14 is 29, so we have 58 equals 29x minus 29. So let's get the x quantity by itself. What we need to do is add 29, and so let's do that for both sides of the equation. So plus 29 on the right side and plus 29 on the left side. Excuse my handwriting. Let's bring that up here. So that gives us 29 plus 58 is equal to 29x. So let's see, 29 plus 58 is 87. 87 equals 29x. And now, what do we need to do to get x by itself? We need to divide it by 29. So we can divide both sides by 29. And that gives us 87 divided by 29, I think is 3. So it gives us 3 is equal to x, right? So x is equal to 3 is our solution for x. So here's an equation with the variable a that we need to solve for inside of fractions. All this does is it adds one extra step where we have to get rid of the fractions before combining the like terms. So how do we get rid of the fractions? Well, we can just multiply this side here by 3, right? Because that'll cancel the 3. Oh, and look, we can multiply this side by 3 also. We'll also get rid of this fraction. So let's just multiply both sides by 3. So what's 3 times 28? That gives us 74. Feel free to do that in your calculator. Plus, and then our 3 will cancel the 3 on the bottom, so we have plus a plus 4. Look at that. The fraction is all gone. Equals, over here, what's 6a times 3? 18a. And then our a over 3 times 3 is just a, so minus a. We can simplify by combining the like terms. We have what's 74 plus 4 is 78. plus A on this side, and then we have 18A minus A is 17A. 17A. So at this point, we can just combine the like terms. Let's subtract an A from this side, and that gives us 78 equals, what's 17 minus A? 16A. Now, our next step, what we need to do is just divide both sides by 16, and that gives us, let's see, that gives us 78 divided by 16 is, I believe, we can divide both of those things by 2, but let's just write it as 78 over 16 for now, equals our A variable. So I'm just going to keep simplifying this number here in my head. Let's just factor it out. What's 78 divided by 2 is, that gives us 39, which I think is a prime number. So that's as far as we can factor that out. And then 16 is 2 times 2 times 2 times 2. So we can just get rid of the 2, and we have 39 over 8. Is our A. So A is equal to 39 over 8. And that gives us our solution for A. And that's the solution for the equation. Equations can also be useful for real-world problems. Here we have a word problem where Jack had twice as many stamps as Ralph, but after he bought 65 and Ralph had lost 16, they found that they together had 688 stamps. How many did each have at first? So we have a statement, and the question is asking for how many did Ralph and Jack have, how many stamps did they have at first? And we can use an equation to figure this out. So let's just look at the problem again. Let's see what numbers they give us. So Jack had twice as many stamps as Ralph. That's important. What that'll probably mean is we can write it as 2x or something like that. But after he bought 65, we'll probably add a 65 there. And Ralph had lost 16. We'll probably subtract a 16 from somewhere. They found that they together had 688. And we'll probably write it as equal to 688. And then here we just have what they're asking for. So let's make a variable. So let's use x. Let's let Ralph's stamps equal x. So we have Ralph's stamps equals x. And so we know that Jack's stamps are equal to 2x, right? Because in the beginning it says Jack had twice as many stamps as Ralph. So how can we write an equation with this? Well, we have the total number of stamps. We can write that. So let's write that up here. The total number of stamps is how many? So what do we need to add up to get the total? Well, we need Ralph's stamps plus Jack's stamps, right? And then is there any other information here that needs to be put in the equation? So after he had bought 65, so we need to add a 65. And Ralph had lost 16. And then we need to subtract a 16. So once again, this equation, we have our total number of stamps equals Ralph's stamps plus Jack's stamps plus the 65 he had bought and minus the 16 that Ralph lost. altogether equaling 688. So that's what you have to do. You just have to look at the problem and make an equation with the information. But now we have an equation that we can solve. So this is the easy part. Let's combine like terms. We have 688 is equal to, right, x plus 2x is 3x. And then 65 minus 16 gives us 49. So let's subtract 49 from both sides. 49. So that gives us 639 is equal to 3x. So now we can just divide both sides by 3 to get the x by itself. And that gives us 213 is equal to x. So what is x again? X is Ralph's stamps. So what's the problem asking for? One thing I forget to do all the time is I'll get through a word problem and I'll forget what it's asking for. So it's important to read again and figure out what the answer will be because they're asking for something specific. So we can write Ralph's stamps here. We know that are just equal to x, right? And x is equal to 213. So Ralph stamps are 213. And we also need Jack's stamps. So Jack's stamps are, so Jack has 2x stamps. What's 2x? 2x is equal to 2 times 213, which gives us, 426. So he has 426 stamps. And so that is the answer to this word problem. Once again, we just read through the problem really carefully and we found all the important information and then we figured out how to make an equation with it. This part is really tricky, making an equation, but you just need to practice it and do your best not to get frustrated. Follow the step-by-step guide if you need to, but do your best to think of the information on your own because it just takes practice. But this is our answer for this problem. So here we have another word problem similar to the one in your homework, but the numbers are changed. There are 100 balls in a bucket. If there are 1/4 as many baseballs as tennis balls, how many of each are there? So first of all, what are we trying to find? We're trying to find how many of each type of ball are in the bucket. So we know we have 100 total balls, and 1/4 of those are tennis balls. Excuse me, 1/4 are baseballs. You have to read carefully. But let's try and write an equation. So we know we have 100 total balls, and what do we want our variable to be? Well, we can let the variable be tennis balls because we know that the baseballs will be 1/4 that. So if we let's let the number of tennis balls equal x, and then we know the number of baseballs is equal to 1/4 x. So how can we write this? We know that we have the number of tennis balls in the bucket plus the number of baseballs in the bucket is equal to 100. So x plus our number of baseballs is 1/4 x. So if we combine the like terms here, we can get 100 is equal to, let's see, 1 plus 1/4 is 5/4 x. So now what we need to do is just divide both sides by 5/4. Let's bring that up here. So 100 divided by 5/4 gives us 4/5, right? Just like we learned to simplify complex fractions. So if you do that, that'll give you, what's 400 divided by 5 is 80. 80 equals x. So the x is 80. What does that mean? We know the number of tennis balls will be 80. So our number of tennis balls is 80. That's one part of our answer. And how do we get the number of baseballs? We just multiply it by 1/4, right? So 1/4 x is equal to 1/4 times 80. What's 1/4? What's 80 divided by 4? That is 20. So the number of baseballs is 20. So gives us our answer for this word problem. Number of tennis balls is 80 and the number of baseballs is 20.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.